boy Jensen, dripped out in his new leather jacket, donned the stage for the opening keynote, and proclaimed that physical AI is the next big thing. So, what on earth is physical AI? Why are they all in? And what does it mean for the rest of us? I'm going to break all of that down and tell you why it's not only important for robotics, but also augmented and virtual reality and geospatial intelligence capabilities. I'm also going to weave in my insights sitting down with NVIDIA's VP of Omniverse and VP of XR technology. But first, let's listen to how Jensen defines the various waves of AI and where we're headed next.
AI has been advancing at an incredible pace since. Started with perception AI. We now can understand images and words and sounds. To generative AI. We can generate images and text and sounds. And now, agentic AI. AIs that can perceive, reason, plan, and act. And then the next phase, some of which we'll talk about tonight, physical AI.
Perceive, reason, plan, and act. When he's talking about that with agentic AI, right? Like where basically you could think of physical AI or robotics really as agentic AI embodied in the physical world, where you're mapping the world, you're perceiving what's in it, you're perhaps planning some set of actions, and then you're executing those actions and kind of doing that in a recursive loop again and again. And so agents can do that in the world of bits on our computers, taking control of everything that we can do on any type of digital system. We need the ability to do that in the physical world too, and that's where physical AI comes in. But let's be honest, controlling a cursor and a mouse and, doing function calling and using a bunch of APIs and tools or whatever to do things inside the digital world is a lot more constrained and easier of a problem than dealing with the messy physical world. So one of the reasons that most large language models are pretty competitive is they've largely got the same training data to work with. In other words, these generative AI models are trained largely off of scraping the public internet, right? And then augmented with some licensed data sets and synthetic data sets. But largely, we're talking about the public web, the text, image, and now slowly the video content that's in it too. But there's actually not that much real world data. This is where companies like Tesla and Google have a huge advantage. Tesla has a fleet of vehicles that are constantly mapping and remapping the world with these noisy sensors, but they're doing it at scale. Or companies like Google that use really expensive sensors to map the world at a regular cadence have a huge advantage. Now, I spent 6 years at Google, and 4 of those were working on Google Maps. And let me tell you, 98% of the world population is covered by Google's data. That is absolutely insane. And from that, you can create these world models with 3 different facets. This photorealistic model of the world, so think about Google Maps Immersive View, Google Earth, all that data that is human readable. The abstracted world model, which is the buildings and the road networks and the points of interest to get you to your latte or get you to your workplace. And then finally, most interestingly perhaps for this conversation, the machine readable 3D world model. And why do you need that? I mean, you think about it like this is a model that is designed for machines to understand and grok the physical world. So if you look at this reconstruction of San Francisco using all of Google Street View data, the colors denote different semantic classes, like different types of entities like sidewalks, trees, poles, road networks. All of that stuff can be pulled apart and machines can understand what they're looking at. Now, if you're not a Google or Tesla, but you need real world training data, NVIDIA has a solution for you. And it involves combining Omniverse with this new offering called NVIDIA Cosmos. Let's take a look.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an NVIDIA CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data.
So let me pause here and just break down what Jensen's talking about, because that was a lot. Basically what they're saying is use something like Omniverse. Think of it like a physically based like game engine on steroids, and effectively create all the scenarios that you want. And this is what's already been happening in the industry. Basically, it's called synthetic training data generation. But what they're doing now is they're using generative AI to make those renders look a lot more like the noisy camera sensors or LiDAR sensors that you might capture these things on, and then kind of reskin it to get all sorts of different types of scenarios covered. So that way, if you have like one really good drive down a street and that data set is awesome, you can now reproduce it for various weather conditions. Now, of course, this should not be a surprise, because if you've seen my Google VO2 review, you know that it can produce some absolutely photorealistic and mind-blowing things. I mean, just look at this dashcam footage that I just gave it a single prompt to generate. Absolutely realistic. I've got the police officers, I've got the light whirring, the police text, everything looks good, the lighting in the back, with the exception that I've got a slumbering dinosaur sitting in the distance. But that was my point. I'm blending reality and imagination. So for example, you might go into your 3D tool of choice and create something like this. I mean, I just took a bunch of assets in Maya, kit bashed them together, and created this sort of like handheld like camera move as if I'm moving through space. And then I can use video to video workflows, in this case, Runway's Gen 3, to reskin it to all sorts of different styles. Now, this is something I've been talking about since like 2022, but NVIDIA is taking it a step further and anchoring it to be far more physically plausible. Again, check this out. I've got the Aurora Borealis in the background. Even the reflections are reconstructed fairly well. You can have like a snow scenario over here. It looks really, really cool. And you've got some of the atmospheric effects coming out nicely as well. And so this is effectively the kind of workflow that Jensen is talking about. So if I go back to Cosmos, you do your ground truth generation, right? Like your LiDAR data, you take your real world captures, you create your CAD-based models, you put them into Omniverse and create a bunch of these training data scenarios, right? Like the car going down the street while a kid crosses it or deer hops in front of it, all this type of stuff. And then basically use that as synthetic training data after you run it through Cosmos to train your robotic AI. And then you go, by the way, test it again inside of Omniverse. So that's exactly what Jensen is showing over here, taking this sort of like crude gray boxed rendition of the model and then basically making it look far more physically accurate using Cosmo. Same example going on over here. Hey, I've got stuff dropping down. Let's make it look like pasta. I'm not sure why that's I'm not sure what robot is going to get trained off of that, but hey, these are keynotes. They're not always super accurate, let me tell you. All right, so what's cool about this, that you can combine sort of the best of generative AI and its ability to be very creative and very quickly give you a bunch of variations, but also the predictability and control, and critically, the physical accuracy of procedural 3D modeling and 3D simulation technologies such as those inside of Omniverse. So here's a Houdini example, right? Like this has been done for video games like Spider-Man, movies. You know, basically you're constructing this 3D rendition of reality. But it is procedural in nature, which means there's rules that govern exactly what's going on, and it's not just going to hallucinate a bunch of crap. And so for things like traffic rules, which, by the way, are pretty governable, you can simulate all of that using these type of procedural 3D modeling technologies, such as the intersection, what happens at a cross section. So why this is important is, rather than hoping that your AI video diffusion model gets the rules of how to navigate this intersection correctly, you can enforce those rules inside your 3D simulation. In this case, Houdini, but really you could take it from Houdini into something like Omniverse as well. You can create the road network, the buildings, and kind of create the rules that govern this universe. I think another great example of this is the Matrix City project, which did heavily use Houdini and Unreal Engine. I would actually argue it's like a Houdini project masquerading as an Unreal Engine project. If you look at this over here, you can very quickly see you've got pedestrians that are also respecting the rules of traffic. And you can have a human entity jump out and the car will stop for you. And so essentially, think of it this way. If you're modeling a city like this playground simulation, if you will, for robots to play around in, you can use that to create synthetic training data. Synthetic training data that is from the perspective perspective of every single camera that you have on your autonomous or semi-autonomous vehicle. And once you render things out, as you can tell, both of these things still look pretty CG. You can use something like Cosmo to go from this rather synthetic looking render to something that looks far, far, far more realistic and accurate to the real world. It has kind of the smudgy, the noise characteristics, all that other stuff that you would get from a realistic sensor. So this is the best of both worlds. Procedural 3D modeling, simulation technologies combined with generative AI. So what's cool is NVIDIA's open sourced a bunch of these models and people are going to do some awesome stuff with it. Now, I will say it is not perfect. I think that's probably why NVIDIA is open sourcing it so other folks can build on it, fine tune on more data sets, look at other methodologies to make it so that this kind of style transfer approach is respects the underlying geometry a bit more and doesn't get too creative, right? You want to constrain the creativity as much as possible. Okay, now let's talk about how this technology applies to augmented and virtual reality. I had a chance to sit down with the homie Rev Libridian, who is the VP of Omniverse and Simulation Technologies at NVIDIA. And we had two amazing conversations. One last year, which you can check out on this YouTube channel, and this past year in December for the TED AI show. Here's what he told me in that podcast interview.
The technologies you all are building aren't just limited to robots, right? As this tech improves spatial understanding, they could enhance our personal devices, sort of virtual assistants. How close do you think we are to that sort of, in real life Jarvis experience, a virtual assistant that can seamlessly understand and interact with our physical environment, even if it's not embodied as a robot?
So this gets back to what I was saying earlier about the definition of a robot.
Yeah,
what is a robot?
Totally.
The way you just talked about that, like, to me, Jarvis is actually a robot. It does those three things. It perceives the world around us through many different sensors. It makes some decisions, and it can even act upon the world. Like Jarvis inside the Avengers movies, it can actually go activate the Iron Man suit.
Right, yeah.
And do things there, right? Like, so what is the difference between that and a C-3PO?
Totally.
Fundamentally.
You're kind of inside a robot, sort of as you alluded to the NVIDIA building too, yeah.
And if you think about some of these XR devices that immerse us into the world, they're half a robot. There's the perception part of it. There's the sensors along with some intelligence to do the perception. But then it's fed into a human brain. And then the human makes some decisions and then it acts upon the world.
Right.
And when we act upon the world, there's maybe some more software, some even AI doing things inside the simulation of that world or that combination. So it's not black or white, what's a robot and what's a human or a human intelligence, where there's kind of a spectrum between these things. We can augment humans with artificial intelligence.
And so I think this is a huge point, right? Like, which is basically that these robots, they're perceiving the world, they're mapping the world, understanding what's in it, they're planning some set of actions, and then they take those actions, right? In the case of augmented and virtual reality, we've got our AR glasses on, or really even using our phone, and the system is telling us, hey, I think you should do this, and then you have to go about executing that. So this halfway a robot analogy is really, really powerful because physical intelligence is just so important. I personally like calling it spatial intelligence, but people like the term physical because, it kind of encompasses more than just spatial understanding. It's visual, spatial, and a bunch of other stuff. And so if you want to say that, maybe physical intelligence is the better term. Let me just say the industry is not very good at terminology because we've got augmented reality, virtual reality, mixed reality, extended reality, and spatial computing as well. So I suspect in this physical AI space, we are going to continue to have a plurality of these terms with various marketing departments going wild. And so I'm going to stick to spatial intelligence as the name of this channel, though I am thinking about changing it to mapping the world. All right, let's move on. This is where I want to bring in what Google is doing in this space. You probably heard about Project Astra. I actually had a chance to go out to the Android XR launch event in New York this past November and go check out these demos and try out their glasses in person. Now, they didn't let us record the demo of the glasses, but I do have a recording of the Android XR demo itself, which I want to show you over here. Also, thanks to Android Authority for covering some of this stuff. So basically, the whole idea here is if you've got a headset or pair of glasses on your face that have cameras, that have depth sensors, that have the ability to understand audio, that read your gestures, you can just say stuff and it will conjure up stuff for you. For example,
hey Gemini, can you bring up my trip planner for me?
Yeah.
Awesome. Up here, you see an indicator to see that Gemini is active, and then a multimodal conversational experience.
And just like that, the familiar 2D Android applications that you know and love.
And not only that, maybe you want to actually like fly over that location and check it out physically. Well, you could do that too. Just say it and it'll pull up immersive view inside of Google Maps and take you there. This is cool to see because that's the last thing I worked on at Google. Hey, show me the inside of the clam. And boom, it'll take you there so you can check it out in 3D. So it's really, really interesting. Like Gemini is front and center in all of these experiences on the XR side, the mixed reality side, sort of a Vision Pro-like headset, but it gets really interesting in augmented reality land too. I had a chance to try 2 pairs of glasses, one with a monocular display and the another with a binocular 3D display. As I mentioned earlier, we weren't allowed to film it, so let me just share my thoughts with you as we see some of these press videos that they did send to me that we could publish. So yeah, basically you see a view exactly like this in the binocular one. It's 3D, it's freaking amazing. Like the glasses look exactly like what you're seeing over here. But as I looked down, I saw this mini map in 3D, and then as I look back up, it goes back to just giving me the turn-by-turn directions. And I didn't think looking at this video it would be as intuitive as it actually was, but it was totally, totally phenomenal. And so when you've got these glasses on, they basically got Gemini 2.0 Flash running, which is really, really fast. And basically it can answer all these questions about the real world. And since it has tool use, meaning that it can use search, it can use maps, it can answer all these crazy questions. I was showing it a bunch of different beverages. I showed it my brand of watch, like what am I wearing? It got all of those things perfectly. Now there were issues at some point. It thought it was using a tool, but it wasn't actually. But I think that's why they didn't want us to film it. It was obviously a very early demo, very reminiscent of sort of what Meta showed with Orion. But what was cool about these things is they just look like a regular pair of glasses, right? Let's say you're walking up to your buddy's place and, you know, it's a building in New York and it has like a key code. You're like, what was that code again? And it pulls it up from your text and tells you exactly what it was and boom. And so I think this is the promise of sort of spatial intelligence merging with augmented and virtual reality. I tried the circle to search functionality too, where basically anything I saw in the digital or physical world, I could quickly just circle it, right? You could do this on smartphones today, Samsung, Pixel, etc. But doing it for the physical world without like having to touch a device or anything with your hands is just so intuitive and exciting. And this is where like the enterprise examples also become pretty clear and obvious. So let's say you're trying to hang these floating shelves. It will give you instructions while your hands are free to do the task that you're doing. But not just hanging shelves, right? The enterprise applications, the kind of stuff that NVIDIA is really into here because there's a clear ROI is also important. So let me take you back to this video from 10 years ago, a work that I did in Deloitte's Emerging Technologies group. Check out this young me going through a maintenance checklist of exactly what to do while being hands-free. And this is sort of the idea, right? Like while you're there remotely at this location, you can have a field service expert that might be sitting in Germany or really far away, getting exactly the point of view of what you're seeing, but not only being able to crudely annotate it with this relative to this QR code, which is what we had to do back then, but do annotations in 3D space and having all sorts of this like AI capability that we just did not have back then. I think this is going to actually absolutely amazing to see. And of course, the local applications are obvious too. Going back to the visual positioning system stuff I showed you, maybe you're just standing out the street and you're like, oh, what's the menu for this restaurant? Okay, cool, I like it. Then you walk up to it. It automatically translates the menu from, in this case, from Korean into English. I mean, the applications are quite limitless, but you can start seeing Rev's point of these devices are halfway a robot. We're just the ones that are kind of operating for it, but they can sense, perceive, and even plan actions in the world. They just have to feed those to us and we have to do them. But then they can respond to our actions and then give you real-time feedback. That's going to be really promising. I mean, just look at things like Samurai. If you haven't seen Samurai, they took the segment anything model by Meta and made it way better, not just at segmenting and detecting things, but tracking them over time. I won't get into the nerdy details because that's the type of stuff I tend to put on Twitter because you seem to like it a little bit more there. But basically immaculate tracking quality. I mean, just look at the baseline versus what you're seeing down here. Combine this with AR, VR glasses, other perception sensor systems, drones, cameras, what have you, and the world knowledge of generative AI models, we're going to have some really amazing capabilities. capabilities on our hands. For example, Dynaduster. So Dynaduster is trained off of a bunch of VR 180 videos, which is also really cool. I had a chance to work on VR 180 cameras and VR 180 content back in my early days at Google. And so you can look at some of the results here. This method is able to predict both the 3D structure and motion from just video frames. You'll be able to infuse new life into 2D sensors and then take 3D sensors, whether they're passive like a stereo sensor or active like LiDAR, to a whole nother level. And there's this whole new wave of millimeter wave mapping technologies that I'm probably going to make a future video on. So let me know in the comments if that's something of interest to you. And that's right, John. It is fucking cool. John's cool, by the way. Former PM of the one and only Photoshop, and currently working on some amazing things at Microsoft. All right, let's get into it. I think the other area where this physical AI is going to get very interesting is not just the understanding of things and places, but the people within them, right? I just gave you an example, taking this to the limit, the work that's happening with Google Relightables or Meta's Codec avatars or the new Starline system. I mean, we're talking about creating photorealistic 3D renditions of us as humans, but all of that, and going back to Jensen's physical AI model, becomes training data so you can infer just as much about a human from a 2D photo or video. And you're seeing that again and again. We have these state-of-the-art methods for full body pose estimation. Now you're going to have the same thing for video and 3D estimation too. We're also seeing as stadiums have started installing a bunch of these machine vision cameras. So you can create these volumetric renditions of what you see. You might have seen this very famously in the recent Olympics, but this has been happening for the last several years, where basically you can create that bullet time effect where you jump in space and then you freeze frame and kind of orbit the camera around it. Under the hood, you can extract a lot of analytics about your players too, and the best teams in the world are using this data to make their plays better. But this technology is only going to get democratized. Another great example of physical AI. And so I think this ability to simulate the world is so important because we've got all of these types of sensor systems, some autonomous, some semi-autonomous, that are out there in the wild. Here, Domjon, with his really cool plugin called Omnistep for Blender, that kind of lets you create these first-person controllers, easily record animations, even do third-person now. Absolutely phenomenal for creating this type of synthetic training data in something like Blender. I think it's going to be very important because it's funny when I was like looking at this happening, right? Like, is there something you can't do? And just a couple days later, I actually got to fly in person. I just realized like how much of this stuff is going to fuse together, especially when I was looking at all the sensor systems that you have inside of these, inside of a cockpit of a real plane that gives you 3D terrain data, sort of where you are relative to it, and very good location estimates, as well as overlaying how the winds are going, because these planes actually try to line up, right? This is where the whole notion of a tailwind comes in, because if you got wind under your tails, let me tell you, you're getting to your destination faster. On the lines of the Omniverse work is where something like Genesis comes in, where like 20 plus labs work together, including NVIDIA, by the way, to open source Genesis. And they're calling it a physics engine with a visual language model agent that helps you turn text prompts into interactive 4D worlds. The idea being that, yeah, you could use something like iCity, for example, inside of Blender, which is another tool that I love, to procedurally model a city. But what if instead of manually clicking stuff on the screen, you could just type in a text prompt and it would seed this 3D environment for you that you could tweak and edit a little bit later. So that's roughly the idea here with Genesis, where no, the model did not come up with this Heineken model. It was a 3D asset, but it composed this scene and animation for you where this dewdrop, where this drop of water kind of slowly rolls down, doing this kind of fluid simulation on top of real 3D models that you can edit, right? And so there's something very exciting about even going upstream of that, where we've got these agents that can now take control of 2D pixels, right, on the screen and click around, that can read 2D pixels and take control of what to click on the screen. They could take those isometric viewports, right, the top, left, bottom, whatever, right, viewport, and start controlling these actual 3D, real world physically accurate simulations. I think what's really, really cool about this is the speed. They're still physically accurate, but compared to ISEC Gym and ISEC Sim, which is the equivalent offering from NVIDIA, they are 10 to 80x faster. So we're talking about simulations that are 432,000 times faster than real time. And I think this is a key point too, which is that when you're out in the real world, you're kind of constrained to what I'll call wall clock time. Time moves at this fixed cadence. Let's not get into relativity and things like that here, but largely we're time constrained, right? We're sort of stuck inside of time, if you will. But these machines are not. You can just throw more compute at it and be completely unconstrained by wall clock time. So you can have robots learn, kind of what would take us thousands of years and do that over an evening, right? The question, really, the dial that you want to scale up is compute. And we've got a really good path to keep scaling that up further and further. Now, what's cool about this is to sort of create a jungle gym environment. Some of these cities are actually open sourcing this data. So the city of Japan has actually open sourced a lot of their LiDAR and city GML data sets so that you can start doing all sorts of really cool things with it. They actually have a goal that by 2030, they want to create what they're calling a complete digital twin where real-time data can be utilized in all fields of decision-making and policy-making. That is an ambitious goal, but it seems they're well on their way. And sort of the idea being, hey, you've got this digital twin, right? Using very expensive sensors, kind of like Google, you go map the world with your LiDAR sensors, with your ground level imagery sensors. So let's say you have the equivalent of ground level street view, LiDAR, aerial imagery, LiDAR, and then you fuse that all together. You've got this like static, high quality digital twin that fixed in time. Then you've got a bunch of these real-time sensors. You've got IoT sensors, you've got security cameras, you've got all sorts of other, sensor fleets that are roaming the world, your Uber cars, your Lyft vehicles, your Teslas, and all of that. So suddenly you can start overlaying changes and dynamic entities on top of this static digital twin. And what's the point of that? Well, if you want to do, for example, a city evacuation scenario, you can go do that with a digital twin. If you're seeing, hey, we want to build this new road, what would that do to traffic in the city? Well, you could simulate all of that. All these what if then else scenarios of the physical world, you can simulate. And not only that, you can also mitigate a whole bunch of risks. Now, NVIDIA is already doing it. They're just doing it on certain parts of the world that they care about. For example, Taiwan, where obviously, like if you have severe weather events that impedes the supply chain of getting NVIDIA's GPUs and chips over to the rest of the world. So using things like Codec, they're actually applying diffusion models to do like super resolution of very coarse-grained data. So let's say you've got this forecast that's of 25 kilometer resolution accuracy, right? Like 25 kilometers is like a very coarse grain map, as you can see. You can go down to 2 kilometer accuracy, right? That's absolutely, absolutely wild. But you can take things a step further, right? So in Taiwan, they're working with the Central Weather Administration to basically use these models to forecast like when typhoon landfalls are going to happen, where are they going to happen with more precision. And this is the coolest part. They're going things a level deeper. Like beyond that 2 kilometer scale, we're going down to centimeter level accuracy now, where you take those like Google Earth style 3D models of the world using other simulation techniques, classical and generative, to figure out wind modeling. And so if you can start predicting this phenomena, like this downwash phenomena that happens, where really strong winds kind of just like screw everything up at ground level, you can block off or issue warnings for those streets. And so this is yet another amazing example of physical AI where we're using other sensors, like space sensors, like satellites, aerial sensors, ground level sensors, all sorts of sensing systems, but still using physical AI to preempt things that happen in the world. So LiDAR is such an amazing data set. Infrared is such an amazing data set, but it's not just helping us now, it's also discovering our past. Just like Japan, there's a bunch of these data sets that are actually sitting out there, and we need to start using not just humans, but AI systems to go look at them. Because a PhD student did exactly that and found a lost Mayan city in a 2013 LiDAR data set. And this happened this past November, so check this out.
I was looking at data that had been collected by a team of ecologists in 2013 who were interested in mapping above ground carbon in Mexico's forests. They were basically looking at the trees. What's really distinctive about LiDAR as a technology is that it's essentially a shower of laser range finding measurements that rain down from an airplane. And it allows you to digitally remove the trees and see the ground anywhere that light could penetrate. And so I took this data set that had been collected in order to look at trees, selected all, deleted the trees, and immediately laughed because I realized that I was looking at a really substantial Maya city that was previously unknown to the scientific community.
So that's crazy. A 2013 data set that was collected for one purpose was looked at by a PhD student at Tulane University who just happened to stumble upon a lost Mayan city. This is where physical AI is going to be an absolute game changer, because we can stop having humans doing this type of stuff and start having machines combing through all this data that we've already collected. I don't think people realize just how much Earth observation data is collected every single day. I've done an entire podcast on this, focusing on weather prediction, but coming back to this over here.
So in this larger area, and it's a data set that consists of a bunch of small blocks and long transects across a large chunk of the Mexican state of Campeche, we found over 6,000 ancient buildings, as well as lots of reservoirs, causeways, plazas, pyramid complexes, palaces, the full spectrum of what you would expect as an expert to find in an ancient Maya city was present in this data set, and none of it was previously known to scientists.
So that blows my mind, right? Like, yes, we've got Street View for all the drivable areas, like where we have population. 98% of the world population is covered by Google Maps data. But there's a huge chunk of the world that has not even been mapped. And I think this is also how we solve our resource problem. By using all of these techniques like LiDAR, ground penetrating radar, we're going to be able to find new mineral reserves that are just sitting right under us, and we haven't gone and looked. Physical AI is going to be a huge part of that. So I'm very excited about this idea of machines that can map the world, understand what's in it, can plan and take actions, execute those actions, and then keep doing that over and over again. Whether we do that with the help of robots, external sensor systems that are looking at weather phenomenon, fire, sports players, or just your presentation. It doesn't really matter. Physical AI is going to underpin all of that. And we're going to be able to access it with a pair of glasses. Because to wrap things up, that's where things are going next. Google's put their cards on the table. They've got their Samsung stuff coming out. There's going to be a bunch of glasses with X-Real. I've already got access to the Snapchat glasses. Meta's going to be coming out with Ray-Bans, which are probably the AR glasses that I use the most right now. But they're now going to have a monocular display, so a display on one of the lenses. And with that, you may have this neural band as well that looks a lot like my Whoop band, and that'll let you basically gesture control and interface with these AI systems. Super, super excited about all of that. And by the way, I think that's very interesting, because perhaps the highest exemplification how physical and generative AI could come together is Mr. Elon Musk. I mean, if you think about it, he's got a satellite grid with SpaceX and Starlink. He's got a self-driving car fleet with Tesla. And even Jensen has said, oh my God, like Elon has a huge advantage. Now he's got Twitter and XAI in our pockets. Neuralink coming next. You tie it all together and you've got full spectrum dominance, baby. And so there you have it. NVIDIA sees their next wave of growth happening in physical AI, spatial visual intelligence, robotic systems, AR, VR, construction, weather forecasting, all this type of stuff is where they're going to see their next wave of growth. And I think this point by Rev exemplifies this beautifully. If you look at the IT industry, right, the computer industry, the world of bits, globally, it's between 2 and 5 trillion a year. Then you look at the world of atoms, the physical world, that's $100 trillion. And let me tell you, that means a lot of NVIDIA GPUs. So that's it for this video. I hope you found it interesting and it gave you a better sense for what exactly is physical intelligence, visual spatial intelligence, all these terms that people keep throwing around, and going a layer deeper than the hype. That's my goal with these videos, to really make this stuff accessible, but actually peel back the onion a couple layers deeper. So if you enjoyed this video, be sure to hit the like button, subscribe for more content like this. And if you enjoyed this and want to get content like this neatly delivered to your inbox, hit up my spatial intelligence newsletter, spatialintelligence.ai. That's it for me. See y'all in the next one. Cheers.